Hello, this is Alkenes Part 2. As you can see on this slide, based upon the formula of C8H14, you can see right here that we have several compounds that are possible. As you can see on the slide, 1, 2, 3, 4 different compounds. Each of these has C8H14 as a molecular formula. Because C8H14 needs 4 more hydrogens to become C8H18, which is C8 and then 2 times 8 plus 2 will give 18 hydrogens. What does the lack of 4 hydrogens indicate? Of course, it went from 14 to 18. It could represent 2 double bonds, like these two in this molecule. Could represent a ring and a double bond. There's a ring and a double bond. Could represent 2 rings, 1, 2. Or it could represent a triple bond. What does a triple bond consist of? And as you remember, it's 2 pi bonds and a sigma bond. And of course, the sigma bond overlapping sp-sp orbitals from the 2 carbons. And then there's a p orbital overlap forming a pi bond and another p orbital overlap forming the second pi bond for the resulting in a triple bond. Okay, on this next slide, alkenes are saturated with hydrogens. The maximum number of carbon-hydrogen bonds possible are present in a saturated hydrocarbon. Alkenes can be unsaturated hydrocarbons because they have fewer than the maximum number of hydrogens. The number of pi bonds and rings is its degree of unsaturation. So unsaturated tells us the presence of double bonds. It's just terminology, saturated versus unsaturated. Now let's look at some nomenclature of alkenes. The suffix of the double bond functional group is ene, or ene. The IUPAC, or the systematic name of an alkene, is obtained by replacing the ane, ending of the alkane name with the same number of carbons, with the ene suffix. So you can see the systematic name, ethene, and as we mentioned earlier, the common name is ethylene. And for this 3-carbon alkene, it's propene. Common name is propylene. You should know both of these common names. Cyclopentene is a 5-carbon ring with 1 double bond. Cyclohexene is a 6-carbon ring with 1 double bond. Now let's look at 6 rules. They're IUPAC rules that apply to alkenes. In the next 6 slides, we're going to spell these rules out. Okay, number 1, numbering to indicate position of bond. We find the longest continuous chain that includes the double bond. That's the first rule. Here's 1 butene. Notice it's between 1 and 2. 4 carbons. It includes a double bond. Here's 2 butene. Again, 4 carbons, but the double bond is between 2 and 3. Here it was between 1 and 2. And here we have 2 hexene with a double bond between 2 and 3. Now this compound here, 2-propyl-1-hexene, notice that the longest continuous chain of carbons that includes the double bond begins right here with number 1, 2, 3, 4, 5, 6. The longest continuous chain, however, that has 8 carbons is across here. 1, 2, 3, 4, 5, 6, 7, 8. However, it does not contain the functional group or the double bond. So we find the longest continuous chain that includes the double bond in order to name the molecule. Now most all acyclic alkenes, which means they're not cyclic, need a number to indicate the position of the double bond. Therefore, normally the position of each double bond should be indicated by a number. As you can see in the slide, 1 and 2 and so forth is indicating where the double bond is. However, with The double bond in a ring or in an alkene of 3 or 2 carbons, there is no ambiguity as to the position of the double bond, so a position number is not needed. For example, ethene, obviously the double bonds between the 2 carbons. Propene, obviously it's between one or at one end of the molecule or between the carbon at the other end of the molecule and the second carbon. And also in your mind's eye, you can think of any cyclic ring with one double bond. It doesn't matter where the double bond is, it's assumed to be between number 1 and number 2 carbons in the ring. So they're always numbered number 1 and number 2. And we'll see some examples of that as we go through here. Here's rule number 2. Numbering direction for substituent chains. Notice that the chain is numbered in the direction that gives the functional group suffix the lowest possible number. That is, trying to get the lowest number on the double bond. So in this example here, 1, 2, 3, 4, 5 gives the double bond between number 2. If we'd numbered it from over on this side, the right side would be 1, 2, 3. It would have been 3-pentene. So we numbered to get the lowest number on the double bond, since it is the functional group. Here's 3-methyl. Notice this methyl group is off of number 3, but 1, 2, 3, 4, 5, 6, 7 gives us 3-heptene, whereas if we had numbered it from the right side, 1, 2, 3, 4, it would have been 4-heptene, which is not as good as 3-heptene as far as naming and nomenclature rules. And here you can see the double bond is way over here on the right, so we're going to number beginning with 1 here. So we have 1-butene, and notice this oxygen in the middle of the molecule. And as you can remember, we can name this as a substituent of the alkene. It's a 1, 2, 3, 4, 5 carbon chain bonded to oxygen, so we can call it pentoxy. It's on number 4, so 4-pentoxy 1-butene. Here's the third rule. Substituents are cited in alphabetical order. Notice that in this slide we have the use of di, di, and you want to make sure you remember that the prefixes di, tri, sec, and tert are ignored in alphabetizing, but iso, neo, and cyclo are not ignored. And this will come up again and again, so rememorize it again. And you remember that sec and tert and neo and cyclo and iso indicate a particular positioning of the carbon bonds around each other. Here's 3,6-dimethyl-3-octene. Dimethyl, there's a methyl group here, and also here on number 3 and number 6, so we call it 3,6-dimethyl. And the double bonds between 3 and 4. So 3-octene, this is the longest chain. And then in the example on the right, we're going to number the molecule to get the lowest number on the functional group, which is the double bond. So 1, 2, 3, 4, 5, 6, 7. And then we have 2 substituents, bromine and a chlorine. So we number it again from right to left, and we have chlorine is number 4 and bromine is on number 5. So, but B comes before C, so we name it 5-bromo, 4-chloro, 1-heptene. Here's rule number 4. In the example on the left, if you number left to right, the substituents are at positions 4 and 7. But if you number from right to left, they are at positions 2 and 5, which is what we're going to do, because we're going to number in the direction to get the lowest substituent number. And again, here's another example on the right. This double bond is in the middle of the molecule. So to do this, we're going to number so that we get 2 and 4 on our substituents. So the bromo group is going to be first in the molecule name. So 1, 2, 3. So bromine gets 2, so it's 2-bromo, and then 1, 2, 3, 4. The methyl group is on number 4. The double bonds between 3 and 4. So 2-bromo, 5-methyl, 3-hexene. However, if we'd numbered from this side, 1, 2, 3, 4, 5, the bromine would have had a 5 on it, which is not as good as having a 2. And also the 3 is indicated right here. So let's continue on with rule number 5. A number is not needed to denote position of the functional group. Now, this is not the case in other compounds. In cyclic alkenes, a number is not needed to denote the position of the functional group because the ring is always numbered so that the double bond is between carbons 1 and 2. As you can see in the slide, the double bond is always between 1 and 2. In cyclohexene, the double bond is between C1 and C2, regardless of whether you move around the ring clockwise or counterclockwise. Now here, we have 1, 2, 3. If we'd numbered it 1, 2, 3, 4, 5, then the ethyl group would have had a 5. But if we number it from this side, 1, 2, 3, it has a lower number. Also, looking at these two methyl groups, 1, 2, 3, 4, 5 results in lower numbers than 1, 2, 3, 4, 5. Actually, it's a tie, but the double bond has to be between 1 and 2. And here's 1, 2, 3, 4. 1, 2, 3, 4. So the double bond is between 1 and 2. Notice we don't have to indicate where the double bond is in this case, in any of these cases, because it's assumed to be between 1 and 2. But then we number it in order to get the lowest number on the functional groups. Very consistent rules. Okay, and now here is an additional slide with examples. For rings, you must move around the ring in the direction that puts the lowest substituent number into the name, not in the direction that gives the lowest sum of the substituent numbers. If you can get a 1, that is great. So here we got 1, 2. 1, 2, 3, 4, 5, 6. 1 is better than a 2, 3. If we can get a 1 on one of these substituents, we'll number it in that way. Here we have a 1 on the methyl group, so we're going to number it 1, 2, 3, 4, 5 instead of 1, 2, 3, 4. 1 is always preferred in our name if at all possible. And then the last slide is here. The direction of numbering should result in the lowest number for remaining substituents. If both directions lead to the same number for alkene functional group suffix and the same low numbers for one or more of the substituents, then those substituents are ignored and the direction is chosen that gives the lowest number to one of the remaining substituents. So, an example, here we got the double bond in the middle of the molecule. 1, 2, 3, 4, 5, 6, 7, 8. Or 1, 2, 3, 4, 5, 6, 7, 8. So it's a tie. However, a 2, 7, 4 balance, but 4 is less than 5. So we're going to prefer to have 2, 4, 7, 4. So the double bond will be between 4 and 5. So we'll number 1, 2 to get the 2 on the bromine, since it comes first. 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. So the methyl group will be on 7. The ethyl group will be on 4. And another example is shown here on the right, as you can see. So those are the rules, 1 through 6.